Hello everyone. Today we'll be looking at the post hoc or item analysis in medical education and its importance and interpretation of the item analysis reports. So uh, we'll be giving some practical examples, and the purpose of this session is to improve the quality of our assessments in medical and dental education. So the learning objectives of this session on item analysis or post hoc analysis is that participants will be able to define what post hoc analysis is and its role in the assessment of examination questions. We'll also be looking at the different key metrics that are used in item analysis, such as difficulty index, discrimination index, the distractor efficiency, and the point biserial coefficient. And finally, we'll be analyzing an item analysis report with practical examples taken from an examination. And finally and lastly, we'll be applying modern tools and best practices and what are the guidelines of different universities uh, in terms of item analysis in medical education. So we'll start off with what exactly is item analysis. So, and when is it conducted? So item analysis is conducted after an exam to evaluate the item performance. By item we mean the items that have been used in the examination, such as the multiple choice questions or short answer questions or any other sort of questions that are used in the exam. And the purpose of this item analysis is to ensure that each question effectively measures student learning and aligns with the objectives. It furthermore, it also adds to the fairness and reliability of the assessment. So another reason why item analysis is important is that it helps in identifying flawed questions. It enhances the test reliability and validity, and it supports the data-driven revisions, and it promotes fairness across diverse learner groups. So now we'll discuss the different values that are present in an ideal item analysis report. So the first is difficulty index. So difficulty index is also known as the p-value. It represents the proportion of the students that have answered correctly, and we'll discuss the ideal range and how to interpret it as it being too easy or too difficult. So the proportion of students that have answered correctly divided by the total responses is the calculated p-value. Now the ideal range for a reliable exam should be around 0.3 to 0.7 for maximum discrimination between high achievers and low achievers, between students who have understood the topic and students who have not. Now, in some universities, there's a rigid mark for it, and they prefer the ideal range as 0.5. For instance, University of Washington. But for some, a range is usually given. Now, if the p-value is more than 0.85, it actually means that more than 85% of the participants or the examinees have found it too easy. While if it is less than 0.3, it means only 30% of the exam participants have attempted it correctly, and it is way too difficult for the rest of the students. So in Dow University of Health Sciences, for instance, the policy is if the p-value is less than 0.2, then it will be flagged. So if only 20% of the individuals can attempt and question correctly, then this item or this question will be flagged. Now the next is discrimination index. So discrimination index shows how well an item differentiates between high and low performers. So, and the formula is given here, where U is the correct in top group and correct in the bottom group. So the correct bottom and the top group means that 27% of the high achievers and 27% of the low performers are actually taken, and then their values are inserted into this formula. So the acceptable discrimination index, which is also known as D, should be around more than zero point 0.2, and if D is less than 0, it indicates that there are potential flaws, and the desirable is that the higher the D value, it shows that it is better, that this item or this question is discriminating between high achievers and low achievers. In Dow University of Health Sciences, if it is more than 0.1, then if it is if it is less than 0.1, then it is usually flagged by the exam software. So then we have the distractor efficiency. Distractor efficiency evaluates the performance of the incorrect options or distractors. So we have the stem, which is followed by the lead-in statement, and then we have options. And within the options, there's one right answer, and then which is the key, and then we have the rest 4 or 5 options which are incorrect. And these are known as distractors. So effective distractors attract some low performers, and each distractor should be able to attract at least some low performing students. And non-functional distractors are those that have been chosen by less than 5% of the students. So ideally, educators or faculty should aim for at least 3 to 5 effective distractors per item. And usually the exam software, it flags if there is more than 1 0 in the distractor. It means 2 distractors are non-functional, then the exam software will flag that item for its distractor efficiency. Now, lastly, we are looking at the point biserial correlation. And this point biserial correlation, or PBS, it's a range, it's a correlation between item score and the total test score. And the range is from -1 to +1. So values of more than 0.2 indicate good alignment with the overall test. Positive, while negative values, they need to be reviewed. And for this purpose, the item needs to be reviewed. So now we'll start off with examples of an item analysis report and how to interpret an ideal item analysis report based on these coefficients. So this is an example of item analysis report where there are 5 items, and so the p-value is the difficulty index, and the D value is the discrimination index, and then we have the distractor efficiency. So the p-value here is 0.65, and this is in the ideal range, where 0.9 it actually shows that it is quite easy, and more than 90% of the students have actually attempted this. And the discrimination is around 0.35, which actually shows that it is able to differentiate accordingly. Now, how to interpret it? So the item 2 with a p-value of 0.9 and its D value is around 0.05 means too easy, and it has low discrimination. So either this item needs to be reviewed or it can be removed from the question bank. So now if you look at the item number 4, it has a p-value of 0.25. So it means only 25% of the exam candidates were able to attempt this p-value. And 0.2 shows that it is around acceptable discrimination. So it's very difficult, but it has an acceptable discrimination. Now, so items with full distractor efficiency shown as in the item 5, if you look at the distractor efficiency, it has 3 by 3. It means that they are well constructed. So we need to have a balanced mix of item difficulties that supports reliability. So here are some examples of software tools for item analysis. So these are the Canvas Quiz Analytics, the ExamSoft Item Analysis, the SPSS, and the Moodle Analytics plugins. The Moodle Analytics plugins are mostly free, but Canvas, ExamSoft, and SPSS, all of these are actually paid software. So now we'll look at some measures of reliability and validity. So Cronbach's alpha is historically has been used uh, for finding out the reliability of an exam test score. So Cronbach's alpha actually shows us internal consistency. And if the Cronbach's alpha is more than zero 0.8, it indicates good reliability. Uh, and it measures, Cronbach's alpha measures internal consistency. So an alpha score of more than zero 0.8 indicates good reliability, supporting the validity of our assessments. So the post-hoc review process involves running reports, identifying problematic items, reviewing content, consulting experts, revising items, and pilot testing. So first of all, item analysis is conducted for after the exam, but before the results have been announced. So, and the exam software then flags items based on the difficulty index, discrimination index, the point parcial coefficient, and uh, and then these items are separated from the rest of the exam, and they are reviewed uh, in terms of the answer key for clarity. Then the content experts are actually consulted for instructional adjustments, whether they want to change a key or whether they want to remove the whole item. And um, and in pilot settings, sometimes retesting is also advised. So what are the best practices and guidelines in terms of post hoc analysis? So the best way is that uh, is to pilot new items unscored to gather stats, but this seems very difficult in summative exams. Uh, but the main hurdle to having good questions is that an item bank needs to be maintained, and it should be aligned with the competency frameworks like EPAs, which combine quantitative and qualitative data and are fully faculty calibrated. So the second thing is that the item bank should be maintained with performance metadata, and the items, they should be aligned with competency frameworks such as the EPAs, the interestable professional activity. Ensure regular faculty calibration on item writing. So what are the common pitfalls and solutions? First, uh, over reliance on statistics without expert review, ignoring non-functional distractors, misalignment with test blueprint, poor documentation, and underusing item banks. So post-hoc analysis is actually ideal for academic, for quality assessment, and to understand how to apply key metrics effectively. So understanding key metrics using modern tools and and integrating findings into continuous improvement samples. And here are some of the references that have been used for this presentation. Thank you, everyone.